Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are solving example from question number 3 from exercise 1.5. So just I read some comment. कुछ बच्चों का कहना है सर हिंदी में पढ़ा है तो मैं हिंदी में भी अच्छा फ्लुएंट बात कर सकता हूँ. कुछ बच्चों का कहना है मराठी में पढ़ा है, महाराष्ट्रियन होने की वजह से मैं मराठी भी बहुत अच्छा कंफर्टेबल बोल सकता हूँ. बट एज पर एज सब्जेक्ट इज कंसर्न, मैथ्स इज कंसर्न, आई एम मोर कंफर्टेबल in English, so that's why it's for me it's better to be teach mathematics in what English. So it is also a language, so give respect to it. So hope you can understand. So well, in question number 3, so it is parametric function x is equal to 80 square and y is equal to 280. It is what? Parametric function, and we have to show that x into y into d2y upon dx square plus a is equal to 0. So to solve this or to find out the value of this expression, we will require the value of d2y upon dx square. So let us try to find out value of d2y upon dx square. So first we are differentiating x with respect to t. So differentiate with respect to parameter t. So derivative of x with respect to t is denoted by dx upon dt. On this side a, keep it as it is. What is derivative of t square will be equal to 2t. Let us denote it by equation number first. Now we are considering value of y is equal to 280, isn't it? Y is equal to 280, it is given to us. Now again we are differentiating it with respect to parameter with respect to t. So dy upon dt will be equals to, on this side 2a, keep it as it is, and derivative of t with respect to t is 1. So value of dy upon dt is also known to us. Once these two values are known to us, then find out the value of second order derivative. So this implies that first order derivative means dy upon dx. So since the functions are parametric function, we have a formula to find out derivative of parametric function. What is that formula? Dy upon dt divided by dx upon dt. Now let us substitute the value. Dy upon dt, its value is equal to 2a, and dx upon dt, its value is equal to 280. Just we are substituting these values. Let us simplify it. Easily we can observe that 2a and 2a from numerator and denominator will get cancelled, and what we are getting? 1 by t. Let us denote it by equation number 3. Once the value of dy upon dx is known to us, now we are trying to find out second order derivative because it will require to solve our example. So therefore d2y upon dx square will be equals to, d2y upon dx square means what? It is derivative of dy by dx, isn't it? So d2y upon dx square means derivative of dy by dx, so which is equal to, but here we can observe that the value of dy by dx is in terms of t. It is in terms of what? T. So we are not able to differentiate dy upon dx with respect to what? X. So because its value is in terms of t, means we have to differentiate it with respect to t, and that's why we are using chain rule here. Already using this method we have completed question number 2 also. तो हम क्या करेंगे? ये dy, इसे y consider करो, dy upon dx can be written as dy, ये dx एक side को ले लेते हैं, and since the value of dy by dx is in terms of t, so that's why I am dividing by t and I am multiplying by t, and this result we have got applying what? Applying chain rule, isn't it? So which is equals to, now d by dt, keep it as it is. Substitute the value of dy by dx, which is equal to 1 by t. This value we are substituting from equation number 3, and dt by dx. What is the value of dt by dx? Dx by dt is 280, so it's reciprocal. Dt upon dx is 1 upon 280. We does not require dx upon dt. We will require value of dt upon dx, means it's reciprocal. So reciprocal of this side is 1 upon 280. Just we have substituted the value. These values we have substituted from equation first and third, isn't it? So now derivative of 1 by t is minus 1 upon t square, and here 1 upon 280, keep it as it is. So which is equal to minus 1 into 1 will be minus 1, and in the denominator 2a write down as it is, and t into t square will be equal to t cube. Let us denote this value say by equation number 4, which is nothing but value of d2y upon dx square. Now we have to show that the value of x into y into d2y upon dx square plus a will be equals to what? 0. Now we are substituting the value. Replace x by its value. What is the value of x here? X is equal to 80 square. So I am replacing x by 80 square. Now replace y by its value. What is the value of y? 280. And now substitute the value of d2y upon dx square. Just now we have got its value. Its value is equal to minus 1 upon 280 cube. And lastly, write down this plus a as it is. Plus a as it is, isn't it? So later on, remaining part is just simplification part. So observe here, 2a, keep it as 2a into a will be equals to 2a square. 2a square. T into t square will be equal to t cube. Again in the denominator, here keep this term as it is, minus 2at cube, keep it as it is, plus a also as it is. Let us check which terms will get cancelled. From this 2 and 2 will get cancelled. From this a square, 2 and 2 will get cancelled. From this a square and a, we are taking division of a square and a. So its division will be a. So a and 1a from numerator and denominator will get cancelled. So here remaining term is a. T cube and t cube will also get cancelled. So its simplification is what? A, and keep this minus as it is, means what we are getting? Minus a. Lastly, keep this last term plus a as it is, and here we can observe that plus a minus a will be equal to 0, means we have shown that value of this expression will be equal to what? 0, which is nothing but our required result. Now see in the second example, what is the given function? Y is equal to e raised to power m tan inverse of x, and what we have to prove here? We have to prove that 1 plus x square d2y upon dx square plus 2x minus 1 minus m into dy by dx is equal to 0. So here we can observe that in this expression value of term of dy by dx and d2y upon dx square also appears. So that's why first let us try to find out value of dy by dx, means we have to differentiate given function with respect to x. So what result we will get here? Dy upon dx will be equals to, on this side, e raised to power f of x. What is f of x? M into tan inverse of x, keep it as it is. We are differentiating it, and whenever we are differentiating we have to apply standard formula. So it is in the form of what? E raised to power f of x. So its differentiation is e raised to power f of x into derivative of f of x, means into derivative of what? M tan inverse of x. So which is equal to, on this side, e raised to power m tan inverse of x, keep it as it is. Now we are finding its differentiation. Observe here, m, keep it as it is. Derivative of tan inverse of x is 1 upon 1 plus x square, isn't it? So now parallelly I am observing our required result also. In the required result here, term of 1 plus x square appears, means to get such type of expression I am shifting this term on this side, and on this side it will 1 plus x square is divided, so on this side it will get multiplied to dy by dx, just using the rules of transformation. So this term will get multiplied to dy by dx. So on this side we will get 1 plus x square into dy by dx. Again observe here, m, keep it as it is, m, keep it as it is, and this e raised to power m tan inverse of x, is it the value of y? Let us denote this by equation number first, and I am replacing it by y from which equation? Equation number first. Just we have simplified this expression, and hope you have got why I am shifting this term on this side, because in our required result that terms appears on the it will be multiplied with what? This differentiation. That's why to get such type of result I am shifting this term on this side. Okay, and you will come to know that it will be helpful to get our required result. Okay, so now we are differentiating it with respect to x. So again differentiate it with respect to x. So on this side, means left hand side, we can observe that here product of two function is there, means to find out its differentiation we have to apply product rule. According to product rule, keep first term as it is, means 1 plus x square as it is, into derivative of second term. What is derivative of dy by dx? Will be d2y upon dx square, plus second term as it is, means dy upon dx as it is, into derivative of first term. What is first term here? 1 plus x square. And on the right hand side, m is constant, keep it as it is, derivative of y is dy upon dx. Okay, so now here we have to find out differentiation of this term. So first let us differentiate it, and later on we will see how to get our required result. So here 1 plus x square into d2y upon dx square, keep it as it is, plus, now here we can observe that differentiation of 1 is 0 and the differentiation of x square is 2x, means derivative of this whole term is 2x, and 2x into dy by dx will be 2x dy by dx, and we can in our required result we can observe that right hand side is 0, that's why take this term on this side. So plus m into dy by dx on this side will become minus m into dy by dx, and which is the remaining term on the right hand side, 0. So well, now compare this expression with our required result. Already we have got first term, and here two terms of dy by dx are there. If we are taking dy by dx common from these two terms, we can observe that we will get our required result. So here this can be written as 1 plus x square into d2y upon dx square divided by d2y upon dx square, and simply we are taking dy by dx common from both the term. So here we will get 2x and here we will get minus m is equal to 0. In this way we have got our required result. Here we have taken dy by dx common from last two term, and this is the result which we want here. Now see the example number 3rd. In this example, what is the value of x? X is equal to cos t and y is equal to e raised to power mt. Using this condition, we have to show that value of this expression will be equal to 0. Here value of x is given to us cos t, and here also y is also in terms of t, but easily we can observe that y is equal to e raised to power mt. So is it possible to find out value of t from this expression in terms of x, and later on we will substitute that value in that expression, means which expression? Y is equal to e raised to power mt. So this implies that t is equal to cos inverse of x. What we will get here? Cos inverse of x. Just simply we are taking cos inverse on this side we will get cos inverse, and if I am taking cos inverse here, cos inverse and cos will get eliminated according to property of inverse trigonometric function. Remaining term is t here, isn't it? Just we have tried to convert t in terms of x. So and y is equal to, what is the value of y? E raised to power mt. So which is equal to e raised to power m. T I am replacing by what? Cos inverse of x, cos inverse of x. So now we have simplified the function. In every case it is not possible, but in this case, in this example, for simplicity I am doing this adjustment. Otherwise we will have a choice, x का differentiation अलग से find कीजिए, y का differentiation अलग से find कीजिए with respect to parameter t, then find out dy by dx, then find out d2y by dx square, and later on try to show that value of this expression is 0. That method is also there, but I am trying here to solve this example using some simple method, because here we are easily able to convert y in terms of what? X. तो हमने पैरामेट्रिक फंक्शन को एक्सप्लिसिट फंक्शन में कन्वर्ट किया. पैरामेट्रिक में थोड़ा सा एफर्ट्स लेने पड़ते हैं, सेकंड ऑर्डर डिफरेंशिएशन के लिए चेन रूल अप्लाई करना पड़ता है, तो यहाँ पे सिंप्लीफिकेशन पॉसिबल था, इसलिए हमने सिंप्लीफाई किया. नाउ वी आर डिफरेंशिएटिंग इट विथ रिस्पेक्ट टू x. सो डिफरेंशिएट विथ रिस्पेक्ट टू x. So derivative of y is dy by dx on this side. To find out differentiation, we can observe that this function is in the form of e raised to power f of x. And what is derivative of e raised to power f of x? E raised to power f of x into derivative of f of x. What is f of x here? M into cos inverse of x. So which is equal to e raised to power m cos inverse of x. Keep it as it is. Now we are finding this differentiation. M is a constant term. Keep it as it is. M, keep it as it is. Derivative of cos inverse of x is minus 1 upon under root 1 minus x square. Once the first order differentiation is known to us, now observe our required result. We can easily observe that this 1 minus x square appears on this side, isn't it? So that's why I'm shifting this term on this side. It will get multiplied to what? Dy by dx. So on this side we will get under root 1 minus x square into dy by dx, and observe the right hand side very carefully. M into minus 1 is minus m, and this whole term e raised to power m cos inverse of x, e raised to power m cos inverse of x can be replaced by y from equation number first. here we are substituting this value from equation number first, isn't it? So this arrangement we have done just to get our required result. Again we can observe our required result, यहाँ पे root नहीं है, isn't it? Means we have to eliminate this root, and to eliminate this root we are squaring both sides. So square on both sides, let us see what we'll get. So square on both sides, we get, see what result we are getting on the left hand side. On the left hand side here, square of first term is 1 minus x square, means root will get eliminated. Here if we are taking square of dy by dx, means we will get dy by dx whole bracket square, and on the right hand side square of minus m will be plus m square, and square of y will be y square. Just simply we are squaring both sides. Now differentiate it with respect to x. So we are differentiating it with respect to x. To find out derivative of this side we have to apply product rule, because here function is in the form of u into v. According to product rule, keep first term as it is, 1 minus x square as it is, into derivative of second term. What is second term? Dy by dx whole bracket square, plus second term as it is, means dy by dx whole bracket square, keep it as it is, into derivative of first term. What is first term here? 1 minus x square. On the right hand side m square, keep it as it is, and derivative of y square. First take power of y as an coefficient, then decrease its power by 1, and derivative of y is dy by dx. Just simply we are differentiating both side. चलो अब इसका differentiation निकालना है और इसका भी differentiation निकालना है. Let us see what result we will get here. So 1 minus x square, keep it as it is, we are finding derivative of dy by dx whole bracket square. This term is in the form of which standard formula? F of x raised to power 2. So first take power of f of x as an coefficient, then decrease its power by 1. So new power will be what? 1. 2 power था, 1 से कम कर दिया तो 1 हो जाएगा. We are decreasing power by 1 into derivative of this f of x, means derivative of dy by dx will be d2y upon dx square. Again observe that it is in the form of f of x raised to power n. First take the power of f of x as coefficient, then decrease power by 1, then derivative of dy by dx is what? d2y upon dx square. What is derivative of this whole term? Derivative of 1 is 0, derivative of minus x square is minus 2x, and minus 2x means derivative of whole term is minus 2x into minus 2x into what? dy upon dx whole bracket square. And on the right hand side, first write down 2, then write down m, then write down y, and lastly write down dy by dx. So now differentiation is completed. Now we are simplifying it to get our required result. Observe the first term. ये term required result में appear है. So what is the first term? 1 minus x square. Again d2y by dx square is also will required. We does not require 2 dy by dx, means we will try to eliminate 2 dy by dx. Second term में हमें x चाहिए और ये square में से 1 dy by dx चाहिए, और यहाँ पे भी हमें 2 नहीं चाहिए. We will require what? m square y. So just 1 minute, here m square is there. Okay, well m square, so m square keep it as it is. Hope you are getting it. M square हमने copy करते वक्त थोड़ा सा गलती हो गई. So m square is there. Okay, so we will require m square also, and y also, means we does not require 2 dy by dx. Means simply now we can observe that in every term 2 dy by dx is there, 2 dy by dx is there, 2 dy by dx is there, and in our required result we have to get our required result we have to eliminate 2 dy by dx. That's why I'm dividing both sides by 2 dy by dx. So divide both sides by 2 dy by dx. Okay, so here if I'm dividing by 2 dy by dx, so remaining term is 1 minus x square. 2 dy by dx will get cancelled, d2y upon dx square, isn't it? Now observe the second term. If I'm dividing by 2, 2 will get cancelled, so minus x, और ये dy by dx whole bracket square में से एक dy by dx अगर cancel हो गया तो यहाँ पे dy by dx बचेगा. Hope you are getting it. So 2 I'm dividing by 2 dy by dx, तो ये 2 cancel हो जाएगा और ये square में से एक dy by dx cancel हो जाएगा, तो यहाँ पे 1 डिवाइड बाई डी एक्स बचेगा. एंड हियर if I am dividing by 2 divided by dx, 2 will get cancelled, divide by dx will get cancelled. What is the remaining term? M square y plus m square y. On this side will become minus m square y, and on this side remaining term will be 0. And check that is it our required result. In this way we have shown that the value of this expression will be equals to what? 0. Now see the example number 4. In this case, what is the given function? Y is equal to x plus tan x, and we have to show that value of this expression is 0. Here also we can observe this expression. We will require the value of d2y upon dx square. So first we are trying to find out the value of d2y upon dx square. So first consider the given function. We are differentiating it with respect to x. So dy upon dx will be equals to, what is derivative of x? 1, and derivative of tan x will be equal to sec square x. In this way we have got first order derivative. Again we are differentiating it with respect to what? X. Now we know that derivative of dy by dx is denoted by what? d2y upon dx square. On this side derivative of this constant term is 0, and derivative of sec square x. To find out its derivative, first observe that function is in the form of f of x raised to power n. So first take this power of f of x as an coefficient, that is 2 as an coefficient, then decrease its power by 1. So what will the new power? 1 into derivative of f of x. क्या है यहाँ पे f of x? f of x है हमारा sec x. f of x raised to power n means f of x is what? Sec x. So which is equal to, not necessary to write 0, write down 2 sec x into, what is derivative of sec x? That is sec x into tan x. Sec x into what? Tan x. So which is equal to 2 into sec will become sec square x into tan x, isn't it? In this way we have got second order derivative, that is d2y upon dx square. So here easily we can observe that this sec square cos square यहाँ पे दिख रहा है मुझे, तो हम क्या करते हैं यहाँ पे ये sec square को क्या लिख सकते हैं हम? 1 upon cos square. So again let us simplify it. 2 tan x keep it as it is in the numerator. 2 tan x keep it as it is. Just take sec square x. Can I write it as 1 upon cos square? Means if we are shifting it in the denominator, its value will become what? Cos square. Again if we are shifting cos square, means if we are taking reciprocal of cos square, we will get sec square. Why we are doing this adjustment? Because in our required result cos square appears. Just shift this cos square on this side. So on this side it will get multiplied to d2y upon dx or dx square. So what result we are getting here? Cos square x into d2y upon dx square, and which is the remaining term on the right hand side, that is 2 tan x, isn't it? So let us denote here this value, say by equation number first, isn't it? And this value let us denote it by equation number 2. Now we are considering the left hand side of our required result. So now we are considering left hand side. What is left hand side? Cos square x into d2y upon dx square minus 2y plus 2x, and simplifying it, let us try to show that the value of this left hand side is equal to right hand side, means 0. Now I am substituting the value of cos square x d2y upon dx square is equal to 2 tan x, because its value from equation number 2 will be 2 tan x. Just replace this whole term by 2 tan x. This value we are substituting from equation number 2. Minus 2 keep it as it is. Why I am replacing by its value? X plus tan x. This value we are substituting from equation number first, and lastly plus 2x keep it as it is. So values we are substituting from equation first and second. Okay, so which is equal to, now let us simplify it. After substituting the value, let us simplify it, and since our required result is 0, we have to show that all the terms will get what? Cancel. So 2 tan x as it is, minus 2 into x will be minus 2x, minus 2 into tan x will be minus 2 tan x, and plus 2x keep it as it is. Let us check which terms will get cancelled. Minus 2x plus 2x, and minus 2 tan x and plus 2 tan x will get cancelled, and in this way we have shown that value of this expression will be equal to 0, and that is our required result here. Now see the question number 5. In this question, one function is given to us, y is equal to e raised to power x into sin bx, and we have to show that value of this expression will be equal to what? 0. And to find out the value of this expression, we will require the value of y1. Y1 means it is the another notation for first order derivative, means dy by dx is also denoted by y1, and y2 means second order derivative, means d2y upon dx square can also be denoted by what? y2. So here we are differentiating this function with respect to x to find out our first required value y1. Already I have told that y1 is nothing but notation for what? Dy by dx. On this side, to find out the derivative, check that we have to apply what? Product rule, because product of two function is there. So according to product rule, keep first term as it is, means e raised to power ax as it is into derivative of second term. What is second term here? Sin bx plus second term as it is, sin bx as it is, into derivative of first term, that is e raised to power ax. So which is equal to e raised to power ax as it is. Now we are finding differentiation of sin bx. What is derivative of sin bx? It is in the form of sin f of x. So its derivative is cos f of x, means cos bx into derivative of what? Bx. Okay, now on this side, sin bx, keep it as it is, sin bx as it is. Now we are finding differentiation of e raised to power ax, and what is derivative of e raised to power x? Means it is in the form of e raised to power f of x. So its derivative is e raised to power f of x into derivative of f of x. What is f of x here? Ax, isn't it? Now let us simplify it. Here e raised to power ax, keep it as it is, into cos bx also as it is. What is derivative of bx? Will be equal to b plus here sin bx, keep it as it is, into e raised to power ax also as it is. Now we are finding derivative of ax. Derivative of ax will be equal to a, isn't it? So once the differentiation is known to us, easily we can observe here in both the terms e raised to power ax, e raised to power ax appears. That's why we are taking e raised to power ax common from both the term. If I am taking e raised to power ax common from first term, here its coefficient means multiple, it's cos bx, and here its coefficient is a into sin bx, means a sin bx, isn't it? So once the value of y1 is known to us, now we are trying to find out second required value, that is y2, means second order derivative. So again differentiate it with respect to x. Let us see what result we will get here. On this side, derivative of y1 will be equals to y2. So derivative of second order derivative is denoted by what? y2. y1 means first order derivative, dy by dx, and its differentiation y2 means d2y upon dx square. Now on this side, to find out the derivative, check that product of two function is there. Yes, product of two function is there. So again here we have to apply product rule to find out differentiation. According to product rule, keep first term as it is into derivative of second term. Derivative of second term means what we will get here? B cos bx plus a sin bx. Again observe here, just simply we are applying product rule. So first term as it is, derivative of second term, plus second term as it is. Second term as it is means what we will get? B cos bx plus a sin bx, keep it as it is, a sin bx means second term as it is, into derivative of first term. Here we can observe that our first term is e raised to power x, that is first term. So just we have substituted the values in the product rule. Now let us simplify it. So therefore y2 will be equals to, y2 is equals to e raised to power ax, keep it as it is, e raised to power ax as it is. Now we are finding its differentiation. B is a constant term, keep it as it is, b as it is. Now we are finding derivative of cos bx. What is derivative of cos f of x? Minus sin f of x, minus sin f of x. क्या है f of x की value? bx into derivative of bx, into derivative of what? bx, plus second term as it is. What is second term? A as it is, and derivative of sin bx will be equals to cos bx into derivative of what? Bx, into derivative of bx, isn't it? So which is equals to, sorry, plus. Now here plus second term as it is, क्या है second term? b cos bx, keep it as it is, plus a sin bx also as it is, a sin bx as it is, isn't it? Now we are finding differentiation of e raised to power ax, which is in the form of e raised to power f of x. And what is derivative of e raised to power f of x? E raised to power f of x into derivative of f of x means derivative of a, isn't it? अभी मैं यहाँ पे derivative of ax, sorry, derivative of ax का derivative orally भी निकाल सकता हूँ. What is derivative of ax? Will be equal to a, isn't it? But board required answer step by step, so don't use jumping step, otherwise maybe possible some examiner will cancel your some marks, delete some marks. Okay, so now what is derivative of bx? Will be b, and b into minus b will be minus b square sine bx. Hope you are getting it. Derivative of bx will be b, b into a will be equal to ab cos bx. Now observe the second term, plus b into cos bx plus a sin bx, keep it as it is. And here derivative of ax is a into e raised to power ax is a e raised to power a e raised to power ax. Okay, now again observe both the term. Can I take e raised to power ax, e raised to power x common from both the term? Yes, e raised to power ax we are able to take common from both the term. If I am taking it common from first term, so here its multiple is minus b square sin bx plus ab cos bx. और यहाँ से अगर हम e raised to power ax कॉमन लेंगे तो यहाँ पे क्या बचेगा? a into this bracket. So I am multiplying by 8 to both the term in this bracket, means see what we'll get. a into b will be equal to ab cos bx, and here a into a will be equal to a square sin bx. So this is the value of what? y2. In this way we have got the value of y2 here. Let us denote the value of y1, say by y by equation number first, y1 by equation number 2, and this y2 by equation number 3. Now we are considering the left hand side of this expression. अभी यहाँ पे adjustment करके ये result तो नहीं ला सकते हम. So that's why first I am considering left hand side, substitute the value, simplified, and try to show that its value is equal to right hand side means 0. So now I am considering the left hand side of our required result, means the result which we have to prove. y2 minus 2a y1 plus a square plus b square into y will be equals to, now substitute the value of y2. This is the value of what? y2 here. So e raised to power ax into minus b square sin bx. Parallelly here we can observe that ab cos bx plus ab cos bx will be twice ab cos bx, isn't it? Plus a square sin bx, keep it as it is, sin bx, keep it as it is. Just we have substituted the value of y2. Then minus 2a, keep it as it is, replace y1 by its value. What is the value of y1? y1 will be equals to, so its value will be equal to e raised to power ax into b cos bx plus a sin bx. Okay, and lastly keep this a square plus b square as it is, a square plus b square as it is, replace y by its value. We can observe that here value of y will be equals to e raised to power ax into sin bx. All these values we are substituting from equation first, second, and what? Third. From these three equations we have substituted the values. Now observe every term here, e raised to power x, e raised to power x, e raised to power x, we are able to take common from all the term. If I am taking e raised to power x common from first term, check that its multiple. This is the multiple. So what will be its multiple? Minus b square sin bx, okay, plus 2ab cos bx and plus a square sin bx. Okay, later on if I am taking e raised to power x common from second term, here its multiple is minus 2a into this bracket. So parallelly I am multiplying by minus 2a to both the term in this bracket. See what we will get? Minus 2ab cos bx, ab cos bx, then minus 2 into second term will be minus 2, a into a will become a square sin bx. okay, and okay, we have multiplied by minus 2a to both the term. Now here from third term, if I am taking e raised to power ax common, so here sin bx into a square plus b square, this will be the remaining term. So I am multiplying by sin bx to both the term in this bracket. So if I am multiplying to first term, sin bx into a square will be equal to a square sin bx, and sin bx into b square will be b square sin bx, okay, b square sin bx. So in this way, this result we have got after taking e raised to power ax common from all the three terms. So which is equal to e raised to power ax, keep it as it is. Let us see what result we will get here. Here we can observe that minus b square sin bx and plus b square sin bx will get cancelled. Then twice ab cos bx and minus twice ab cos bx will also get cancelled. A square sin bx and minus a square sin bx will also get a square sin bx plus a square sin bx is twice a square sin bx. Twice a square sin bx and minus twice a square sin bx will get cancelled, means all terms will get cancelled. So here we are getting 0. 0 into any number will be equal to 0. In this way we have got our right hand side, means by considering this left hand side we have shown that its value is equal to 0, means what? Right. Now let us try to solve the example number 6. What is the given function? Sec inverse of 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to m, and we have to show that its second order derivative will be equal to 0. So here we can observe that this is implicit function, and such type of example already we have solved in the exercise of implicit function, and in such cases near about 6-7 examples are there of this type, in which we have shown that first order derivative will be equal to dy by dx. Let us again use the same method to show that first order derivative will be equal to dy by dx, and later on we will try to find out its second order derivative also. So here we are taking sec on both sides. If I am taking sec of left hand side, sec and sec inverse will get cancelled, means remaining term is 7x cube minus 5y cube divided by 7x cube plus 5y cube, and on this side we will get sec m. This result we are getting just simply by taking sec on both sides. On this side we will get sec m, and on this side sec, if we are taking sec and sec inverse will get eliminated by property of inverse trigonometric function. Now here we can observe that sec m, is it a constant term? Yes, variable does not appear. Which are variable? X and y. So this constant I am denoting say by k. Let us denote it by k. So since we are denoting it by k, so let us suppose that this constant term will be equal to what? K. So on this side 7x cube minus 5y cube, keep it as it is, this denominator will get multiplied to k. So on this side we will get 7k x cube plus 5k y cube, means this denominator will get multiplied to k. Now on one side we are collecting the terms of x. So here 7x cube, keep it as it is, this plus term on this side will become minus 7k x cube, isn't it? Collect remaining terms on right hand side. So 5k y cube, and this minus term on this side will become plus 5y cube. From first two term we are taking x cube common. So here what we'll get? 7 minus 7k, and on this side if we are taking y cube common, what we will get? 5k plus 5. Just simply on this side we have taken y cube common, and on this side we have taken x cube common. So therefore it can be written as y cube divided by x cube will be equals to, just I am taking this term on this side, means ये जो कोएफिशिएंट है इधर आके डिवाइडेड होगा और x cube इधर आके डिवाइडेड होगा, just using transformation. So y cube upon x cube will be equal to 7 minus 7k divided by 5k plus 5. चलो ये टर्म इधर डिवाइडेड होगी और ये टर्म इधर आके डिवाइडेड होगी, isn't it? So what we are doing here, we are trying to collect the terms of variable on one side and constant term on another side. Why? Because if we are collecting constant term on another side, then after differentiation we know that derivative of constant term will become 0. यहाँ पे भी हम differentiate कर सकते थे, यहाँ पे भी, लेकिन हमें ज़्यादा efforts लेने पड़ते थे to get our required result. अभी यहाँ पे भी हम डिफरेंशिएट कर सकते हैं. ऑन दिस साइड वी आर एबल टू अप्लाई क्वोशिएंट रूल, लेकिन लेकिन यहाँ पे हम कोशिश करेंगे कि ये फंक्शन और सिंप्लीफाई करने का, मीन्स वी आर ट्राइंग टू सिंप्लीफाई दिस इक्वेशन, मीन्स वी आर ट्राइंग टू कन्वर्ट इट इन द सिंपलेस्ट फॉर्म सो दैट डिफरेंशिएशन बिकम व्हाट इजी। ओके, यहाँ पे भी डिफरेंशिएट कर सकते हैं आप u बाई v से, लेकिन हम सिंप्लीफाई होता है इसलिए हम सिंप्लीफाई करने की कोशिश कर रहे हैं। सो वी आर टेकिंग क्यूब रूट ऑन दिस साइड, सो इफ वी आर टेकिंग क्यूब रूट, so here we will get y upon x, cube will get eliminated, and if we are taking cube root on this side we will get 7 minus 7k divided by 5k plus 5 raised to power 1 by 3. 1 by 3 means what? We have taken cube root, so we have just simply taken cube root on both side, so we will get this result. अब यहाँ पे left hand side और simplified form में आ गई, so now we are differentiating it with respect to x. So differentiate it with respect to x. So on this side, to find out the differentiation we have to apply quotient rule. According to quotient rule ki v as it is means x as it is into derivative of y means derivative of y is dy by dx plus u as it is, u means what? Y as it is into derivative of x divided by v square means square of x, and on the right hand side derivative of constant term will be equal to 0. So therefore x dy by dx, keep it as it is, plus y also as it is, derivative of x will be equals to 1 and x square into 0 will be equals to what? 0. Sorry, here minus is there. According to quotient rule, v as it is derivative of u minus u as it is, minus is there, and ये x square इधर आके 0 को multiply हो गया तो 0, x square into 0 will be equal to what? 0. So on this side x dy by dx, keep it as it is, and this minus y into 1 means minus y, on this side will become plus y, which implies that dy upon dx will be equal to y by x. X will get divided on this side. In this way we have got the value of dy by dx. Let us denote this value by equation number first. Now question is to find out the value of second order derivative. So again we are differentiating it. So again differentiate it with respect to x. Let us see what we'll get. Derivative of dy by dx is d2y upon dx square, isn't it? And on this side, to find out the differentiation, we have to apply quotient rule. According to quotient rule, v as it is means x as it is into derivative of u means derivative of y is dy by dx minus u as it is means y as it is into derivative of v. What is v here? X divided by v square means x square. Just we have substituted the values in the quotient rule. This is u and this is what? V. Okay, now let us simplify it. X, keep it as it is, replace dy by dx by its value. What is the value of dy by dx? Is it equal to y by x? Yes, its value is y by x. From which equation? First, y, keep it as it is, here derivative of x is 1 divided by x square as it is. This value we have substituted from equation number first. Which value? Dy by dx I am replacing by y by x. So which is equal to x will get cancelled, remaining term is y, and minus into y will be minus y divided by x square. So here y minus y will be 0 divided by x square, and 0 divided by x square will be equal to 0 because 0 divided by any number is 0. In this way we have shown that the value of d2y upon dx square will be equals to 0, and that is our required result here. See in the next means example number 7th. In this example, one function is given to us 2y is equal to under root x plus 1 plus under root x minus 1, and we have to show that value of this expression is 0. In this expression, term of y1, y2 appears. y1 means first order derivative, y2 means what? Second order derivative. So first let us try to find out first order and second order derivative, and later on we will try to get our required result. Okay, so here we are differentiating it with respect to x2, keep it as it is, derivative of y is y1, isn't it? Because here differentiation is denoted by y1, that's why I am also denoting differentiation by y1. On this side, first find out derivative of first term, which is in the form of root f of x. So its differentiation is 1 upon 2 root f of x. What is f of x? X plus 1 into derivative of x plus 1 means derivative of f of x. Plus again we can observe that second term is also exactly in the form of what? Root f of x. So its differentiation is 1 upon 2 2 root f of x means x minus 1 into derivative of f of x. What is f of x here? X minus 1. So which is equal to, differentiation of this whole term is 1. 1 into this term will be 1 upon 2 under root x plus 1. Okay, plus here also derivative of this whole term is 1. 1 into 1 upon 2 under root x minus 1 means we will get the same term. Okay, so now I am taking to simplify it, on this side I am taking cross multiplication, and for the before that I am taking 1 by 2 common from both the term. Okay, I have taken 1 by 2 common, and now I am taking cross multiplication. So under root x minus 1 into 1 will be under root x minus 1, plus under root x plus 1 into 1 will be under root x plus 1. Hope you are getting it. I have already taken 2 common, and in the denominator we will get product of these two terms, means under root x plus 1 into under root x minus 1. पहले ही हमने 1 by 2 कॉमन लिया है, और and then we have taken cross multiplication of remaining terms, isn't it? And on this side 2y1, keep it as it is. Now I am shifting this term on this side, so 2 on this side will get multiplied, so on this side will get 4y1 is equals to, now this numerator, observe the numerator very carefully. So can I replace it by 2y from equation number first? So I am substituting or I am replacing under root x plus 1 plus under root x minus 1, under root x plus 1 plus under root x minus 1 by what? 2y, and this value can be substituted from equation number first, and in the denominator, observe the denominator, here terms are in the form of root a into root b. What is the product of root a into root b? Will be root a into b, means x plus 1 into x minus 1. So on this side 4y1, keep it as it is. Parallelly I am cancelling 2 on both sides. Check that both the sides are divisible by 2. Yes, so on this side we will get 2 if I am dividing to left hand side by 2, and since I am dividing to right hand side by 2, so 2 will get cancelled. Here we will get y, and in the denominator, observe the term in the denominator, it is in the form of a plus b into a minus b, so its product is a square minus b square. A square means x square minus b square means square of 1 will be equal to 1. Now we can observe that this term appears on this side in our required result. So that's why I am shifting this term on this side. So on this side what we will get? 2 into under root x square minus 1 into y1, and on the left hand side remaining term is what? Y. Just ये divided है, इधर आके क्या होंगे? Multiply. Now again we are differentiating it, so differentiate it with respect, before differentiating, observe that in the required results root is not there, so to eliminate this root we are squaring both sides, so square on both sides. Let us see what we will get here if we are squaring both sides. So square of 2 is 4. Here if you are taking square, so here we will get x square minus 1. What is square of y1? y1 square. On this side y square. Just simply we are squaring both sides, isn't it? Now to find out differentiation of this side we have to apply product rule. So we are differentiating left hand side, applying product rule. So here 4, keep it as it is. First term as it is, means x square minus 1 as it is, into derivative of second term. Now second term is in the form of f of x raised to power n. First take power of f of x as an coefficient, then decrease its power by 1, then derivative of y1 will be equal to what? y2. Okay, first term as it is, derivative of second term plus second term as it is. What is second term? y1 square as it is into derivative of first term. What is first term here? X square minus 1, and on the right hand side derivative of y square will be 2y dy by dx. Derivative of y square, take power as coefficient, decrease power by 1, then derivative of y is dy by dx. Now we are simplifying it to get our required result. Now we are very close to our required result. Just find out differentiation of this term. So here I am multiplying by this 4 to both the terms in this, otherwise okay, multiply by 4. So 4 into 2 will become what? 8 x square minus 1 y1 into y2, plus here what is differentiation of this term? 2x into y1 square, and on the right hand side 2y, keep it as it is, 2y as it is, dy by dx, can I replace it by y1? Yes, dy by dx means what? y1, फर्स्ट ऑर्डर डेरिवेटिव. तो यहाँ पे भी आप इस dy by dx को क्या कौन सा नोटेशन यूज कर सकते हैं? y1. सो वी हैव टेकन पावर एज कोएफिशिएंट, डिक्रीज पावर बाय 1, देन डेरिवेटिव ऑफ y is denoted by what? y1. Why we are denoting it by y1? Because in our required result they are denoted it by y1. Now here in the first term x square minus 1 and y2 is required, which already we have got. तो हमें यहाँ पे क्या नहीं चाहिए? 8 में से 2 कैंसिल करना पड़ेगा टू गेट रिक्वायर्ड रिजल्ट, और y1 भी नहीं चाहिए, यानी 2y1 इलिमिनेट करना है टू गेट आवर सेकेंड टर्म. ऑल्सो वी हैव टू इलिमिनेट व्हाट? 2y1, ये y1 में से एक y1 निकालना पड़ेगा, और यहाँ पे भी 2y1 अगर इलिमिनेट किया तो हमें हमारा रिक्वायर्ड रिजल्ट मिल सकता है. मीन्स टू गेट आवर रिक्वायर्ड रिजल्ट वी आर डिवाइडिंग बोथ साइड बाय, डिवाइड बोथ साइड्स, ऑब्जर्व इट वेरी केयरफुली, वी आर डिवाइडिंग बोथ साइड्स बाय 2y1 टू गेट आवर रिक्वायर्ड रिजल्ट. चलो यहाँ पे 2y1 से डिवाइड किया तो यहाँ पे बचेगा 4x स्क्वायर माइनस 1 एज इट इज, और ये y1 कैंसिल हो गया तो क्या बचेगा? y2. अगेन हियर 2 विल गेट कैंसल, x एज इट इज, y1 स्क्वायर में से एक y1 अगर बचेगा कैंसिल होगा तो बचेगा y1, एंड हियर आफ्टर कैंसिलिंग 2 एंड y1 रिमेनिंग टर्म इज व्हाट? y. नाउ वी आर शिफ्टिंग दिस y ऑन दिस साइड बिकॉज आवर राइट हैंड साइड इज 0. सो 4x स्क्वायर माइनस 1 into y2 plus xy1 plus y on this side will become minus y, and on the right hand side we are getting 0, and this is the required result.